Hello everyone, this is Mortaza. Welcome back to the Coder's Journey. In this episode, we are going to pick up where we left off. In the last video, we talked about the LSP or Liskov Substitution Principle. As you might remember, the LSP is all about the inheritance and the hierarchies, right? And it is, talking basically about the relationships between your subclasses and your superclasses. In the last video, we kind of talked about the basic idea of LSP, and in this video, we are going to talk about the first rule of LSP, and probably we will cover the subsequent rules as well. So first off, if you haven't watched the first video about LSP, please make sure you do, because as always, what we are covering in this video is kind of based upon the ideas of the last video. Anyway, let's get going and let's talk about the first rule of LSP. So the first rule is that there should be contravariance between parameters of the base class as methods. So in this example, we've got a base class, animal, right? So contravariance between the parameters of the base class as methods, for example, the eat method in the base class, the parameter with what? With the matching parameters in the subclasses. So the first part of the first rule says that between the parameters of the methods of the base class and the parameters of the corresponding methods or the matching methods of subclasses, there should be a contravariance relationship. So what is this contravariance? Contravariance means that the parameters in subclasses must either be the same type as those in the base class. So this should either be of type food, which in this case isn't, right? Or must be less restrictive. So as you can see here, we do not have the same type for the eat method, but the type is less restrictive. So the food is less restrictive than the type meat. So this is the first part. So once again, between the parameters of the methods of the superclass and the parameters of the matching methods in the subclass, there should be a contravariance relationship, meaning that they must be either of the same type or this must be less restrictive. So this is more restrictive, right? So meat is of course more restrictive or more specific than food. Food is, more general. Similarly, there must be covariance between method return values or return types in the base class and its subclasses. So for example, in this example, as you can see, the example of return types or return values, here we've got a method draw in the superclass which returns an object, and we have a matching method in the subclass circle which is returning a circle. So circle is more restrictive than object, right? So it is more specific. Object is very general. Let's go over the rule one more time. So there must be covariance between the method return values in the subclass and its superclass or base class and its subclasses. This means that the return type of the methods in the subclass must be either of the same type or more restrictive than the return type of the methods in the superclass. Here, of course, circle and object are not of the same data type, but it is more restrictive. Circle in the subclass is more restrictive than object in the superclass. So basically, the first rule of LSP is about the parameters, right? The input parameters of the methods, as well as the return types of those methods. The methods which are both in the superclass and the subclass. Now let's move on to the next rule. The next rule concerns preconditions and postconditions. Now, first we need to talk about preconditions and postconditions. We need to know what these are. A precondition of a class is a rule that must be in place before an action be taken. In English, pre means before and post means after. So precondition is a condition, is a state that must be in place or that must hold true before an operation begins. And post condition is a condition that must hold true after a certain operation completes. So for example, before calling a method that reads from a database, you may need to satisfy the precondition that the database connection is open. So if you have an operation for reading from a database, a possible precondition would be that the connection to the database is open. So this is a possible precondition, right? And the post condition describes the state of objects after an operation is complete. For example, it may be assumed that the database connection is closed after executing SQL statement. So LSP states that the preconditions of a base class must not be strengthened by a subclass and that postconditions cannot be weakened in the subclasses. So once again, the second rule of LSP is about the preconditions and postconditions of superclasses and subclasses. We talked about preconditions and postconditions, and according to this rule, the preconditions of a superclass cannot be strengthened or become more strict by a subclass. And also the postconditions cannot be weakened in subclasses. We're not gonna go over, a sample for this rule. We will probably talk more about it in C# in the next video, because I want to kind of, talk about every single rule here, and we still have 5 of them left. Let's move on to the next one. The next rule is about invariants. Now, invariants are rules or conditions that must always be true. So if, for example, a class has a condition that should always be true before starting a certain operation and after that operation is complete, that is called an invariant. So an invariant describes a condition of a process that is true before the process begins and remains true afterwards. For example, a class may include a method that reads text from a file, right? So we have a class and we are reading from a file. If the method handles the opening and closing of the file, an invariant may be that the file is not open before the call or afterwards. So suppose that a method is reading from a file. Before the method starts, the file is closed, then the file gets open, the content is read from the file, and after the method is done, the file will be closed again. So the invariant is that the file is always closed, right? Before the operation and after the operation. To comply with the LSP, the invariance of a base class must not be changed by a subclass. So in terms of invariance and the relationships between a superclass and a subclass, we should always be careful not to change the invariance of a base class in a subclass. The next rule is about history constraint. By their nature, subclasses include all the methods and properties of their superclasses. Of course, all the, public and protected members. They may also add further members. Of course, a subclass can add, methods that it specifically wants or some other properties as well. So the history constraint says that new or modified members should not modify the state of an object in a manner that would not be permitted by the base class. For example, if the base class represents an object with a fixed size, like for example a square, we all know that a square is a shape with 4 sides and the length of each side is of a fixed length or a fixed size, right? So this is the state or the behavior, the characteristics of a square, right? So suppose we have a base class which represents a square. So if the base class represents an object with a fixed size, the subclass should not permit the size to be modified. So this is history constraint. We know that subclasses can add their own specific properties and methods, but adding these properties and methods should not change the state of an object of the base type in a way that it is not permitted by the base type. And the final rule of LSP specifies that a subclass should not throw exceptions that are not thrown by the base class, unless they are subtypes of exceptions that may be thrown by the base class. So the last rule is about throwing exceptions. We all know that we throw exceptions in our code, right? So the exceptions that a subclass throws should be either of the same type of the exceptions from the base class or the exceptions that are derived from those exceptions in the base class. Now, one important thing about these rules is that these rules cannot be controlled by the compiler or an object-oriented language like C#. Instead, we, as the programmers, should always consider the design of our classes and the relationship. Of course, I'm talking about, inheritance hierarchies, so that these rules are, met. So if we fail to do so, risks of the creation of subclasses that break rules and create bugs and types are very probable. So we should, as programmers, be careful about respecting these rules because our programming language or the compiler cannot enforce them. One last paragraph. One common indication of non-compliance with the LSP is when a client class checks the type of its dependencies. Been there, done that, and I'm sure that you guys have also done this as well many times. We have all seen methods with parameters, and then in the body of those methods we have a switch statement or some conditional statements that check the type of the input parameter, and based on the type we do different things. For example, if the input is of type, rectangle, we do something. If it is of type square, we do something else. If it is of type circle, we do something else, right? So if you have a method that checks the type of an input parameter to do a set of different operations, this may be an indication of the violation of LSP. And this additional complexity not only violates LSP but also violates OCP or open close principle, because whenever you add a new type, like for example an oval or a triangle, you need to go to that method and add another branch for your switch statement or your if conditional to treat or to incorporate that new type as well. So one more time, when you have a method that checks the type of an input parameter, this might be by reading a property of an object that artificially describes its type. For example, you have a string property in a type which is filled in with the type of that object. Or if you are a more advanced programmer, you will probably use reflection to obtain that type. And then based on that type, you do different things, often with a switch statement, right, to perform a different action according to the type of the dependency. This additional complexity also violates the OCP because, as I told you, whenever you add a new type, you need to go and add new branches to that switch statement or conditional. And this added complexity not only violates OCP but also LSP, because the client class need to be modified whenever your new subclasses are introduced. These are the rules about LSP. In the last video, as I told you, we talked about the basic idea. Please watch that video as well. And in this video, we talked about the different rules. As I told you, these rules cannot be considered or enforced by your compiler or your programming language. You as the programmer are in charge. You should always step back and take a look at your code and carefully think about the fact that you are respecting these rules or violating these, because if you violate them, chances are you are writing error-prone code, and a code that is, has the potential to make a lot of bugs. I'm gonna finish this video here. In the next video, I will probably come to Visual Studio and start coding and talking about LSP in a practical example, and tell you guys all about the techniques and the different concepts of LSP using a practical example. If you haven't subscribed to A Coder Journey, please make sure you do watch my previous videos and stay tuned for my upcoming uploads. Till later, stay awesome and keep coding. Bye-bye.